All right. Welcome back to reading break. I hope you had a nice break. I hope you finished everything that you were hoping to finish. I never do. Never. All right. And it was pink shirt day during reading break, so I didn't get to wear my, I guess it's not really showing up as pink, but it's bright pink. On Wednesday, I think it was. I like to show it off sometimes. All right. We're just going to jump right in. I know that's kind of rude, but in terms of review, this next section will be review. Okay. And so before the break, we used, and I guess, sure, maybe let's do a little bit of review just to dust off the cobwebs. I clearly didn't, I was typing a lot over reading break, but not writing a lot. And so you can really tell it's like back from summer again. Before the break, we used the future value formula equals P times 1 plus R times T, right? To solve for future values, present values. We could also solve for the rate, R, the interest rate, and time. Okay. To solve problems involving the future value, the present value, the interest rate, and time. Okay. That's really all we did. We rearranged this formula. If you just wanted to use the rearranged formula, that's totally fine. But we solved problems using these, and our focus was really, we focused on these, right? You can solve for R and you can solve for T, but most of the time we want to know, okay, if I deposit this amount of money today and I want to take it out in 2 years from now, how much will I have, right? And so the present value is that first amount of money, and then the future value is how much I'll have 2 years from now, right? Or if I need to have $10,000 in 5 years, how much do I need to invest today? Right. And so, and we did combinations of those things. And the next section, oops. Let's see here, section, I'll just call it by name. Section 4.6 will serve as review for these concepts. Will serve as review. We already solved these problems in 4.5 and 4.4. I will add that. We already solved some problems like this. Some equivalent, I'll just call it, again, I'll call it by name. Where is the video? The video. Let me go to my Moodle page. And at the top here, there's a link to lectures on YouTube. And it'll link you to our playlist. But if you wanted to study ahead, then that's totally fine. You can find a different Math 114 playlist from before, and I basically just do it all over again. So if you wanted to watch ahead, you can, but here's where I post the videos. Okay. Yeah. So hopefully that helps. Okay. I'll close that so it doesn't take up any bandwidth. So we already solved some equivalent payments problems. In 4.4 and 4.5. But we didn't call them that. Okay, awesome. But that's okay. So now we're gonna actually call them that, and we're gonna just do more practice. Okay. One thing to note is that these concepts are gonna come up again when we move into chapter 5. The only thing that changes in chapter 5 really is how we calculate the interest rate. Okay, that's the only thing that changes, right? And how the interest rate behaves. It's going to be a little bit more complicated than simple interest, which is what we're doing now. But the ideas of solving these problems stays the same. Okay? So we're going to use these concepts in chapter 5, in chapter 6, in chapter 7, and chapter 8. So we are going to get really comfortable with it, but we're just warming up, right? All right. So equivalent payments. Equivalent payments are two payments that are the same, right, over time. And we've seen that before, right? Where if I invest $950 today and I wait a year, I might have $1,000, right? And so that's the time value of money. And so let's see here. Let's define equivalent payment. Equivalent payments. Oops. Are two payments that enable you to end up at the same dollar amount at a later date. I'm just trying to think if there's a better way to say that, but I'll just go for it. Two payments that enable you to end up, oops, that doesn't look like two, does it? To end up at the same dollar amount at a later date. Baked into this is the idea of a payment stream, which we've seen before. We didn't call them that. So same thing, we've seen equivalent payments. We didn't call them that. And now we're talking about payment streams, which we've seen, but we didn't call them that earlier. Okay. And so that's why it's such a nice review section. It's almost like I timed it. So the payment stream, I had to work ahead a little bit. A payment stream is exactly as it sounds. It's a series of multiple payments, right? So two or more payments to pay off some single transaction. So think about, you buy a car, you make payments on that car for a certain amount of time, and then it's paid off, right? Or you borrow money from a friend and you say, oh, I'll pay you half back in 2 months from now, and then I'll pay you the rest in 6 months, right? That kind of thing. And so, so that's what we're going to be dealing with. So that's a payment stream. So a series of two or more payments required by a single transaction or contract, right? Thinking about maybe a lease or something like that. Okay. All right. Another term that I just want to to define, just because it might come up in questions that you're working on. I'm not going to use the focal date so much, but I might say it sometimes, so I should define it, right? But the focal date is going to be the date that you're interested in, okay? And later, when we're drawing our timelines, it's the date that all the arrows go to. Okay, you can have multiple focal dates. Usually there's only one, but you can have multiples. But the focal date is exactly that. It's where your payments are moving to. Okay. So the focal date is a date. Oops. Date of importance to our calculations. Usually, it is the date that we are drawing our money to, right, in terms of a timeline. Usually, it's the date we are drawing our money to in a timeline. I just realized I forgot to end the review, but it was pretty obvious. Started a new section here. So we'll start with an example, and I'm going to do example 159. I will also note that I snuck in example 161, which is not posted on the examples in Moodle. So I'll try to remember to repost this, but otherwise just add it to your list. But we're going to do 159 first. Okay. A particular investment pays $800 payments for 8 and 12 months from now. What's the most an investor should be willing to pay for this investment today if money earns a rate of return of 6%? Okay, and it does say use today as the focal date, which means that in our timeline, right, we're going to draw all our money arrows or our time arrows to today. Okay. So first thing I want you to do is just go through and usually, you know, if I'm working on paper, I'll just kind of jot down the dates kind of somewhere over here, right? So 4 months, 8 months, 12 months from now, right? Which means that I should probably have now somewhere on there, but usually we call it today. Okay. And then it has used today as the focal date. Besides that, I don't see any other dates. So remember, right, when you're reading these questions, the first thing you want, well, you want to read the question, try to figure out what you need to do. And then even if you can't figure out what you need to do exactly, start by making a timeline. Okay. And on that timeline, I usually divide it up equally, right? And I just make sure that I have spots to put all the dates that are mentioned in the question. Okay. So I usually do something like this. And then now I know, okay, 1, 2, 3, 4 ticks on my timeline. Okay. So I erase this because I don't actually need it. I just needed it to figure out how many ticks to put on my timeline. And make sure you fill the entire page, right? There's no reason not to, and it just makes it look a little bit cleaner. Okay. So I need 4 ticks on here, which means I have 2. And so I'm just gonna throw down 2 more, and now I have 4. Okay. And so now I'm gonna say, okay, well, here's today. 4 months, 8 months, and 12 months from today. Okay, so it doesn't really matter. 4 months, 8 months, and 12 months from today. Okay. So the dates go up top. Okay. We're working online, so I'm not going to be marking your timelines necessarily. But it's just a good skill to have, to be able to make timelines properly. Okay, so this investment is going to pay you $800 4 months, 8 months, and 12 months from now. Okay. So in terms of the dollar amounts, let's do this. The dollar amounts are 800. Okay. $800 4 months from now is not $800 today, right? Because I could take some amount of money and put it in the bank in theory, right? And I guess in reality as well, right? But I can take some amount of money, I can bring it to the bank and I can say, can you hold this for 4 months and give me interest on it? They say, you betcha. But the interest rate is kind of weird right now. So it's not, you're not going to make a ton of money, but a couple of dollars maybe, right? And then I let it sit there for 4 months and then I'll have $800. Okay, so there's going to be a present value of that $800 4 months from now. Okay, the present value 8 months from now, right, is going to be what? Less, right? Because it got to sit there for longer. Okay, so how are we going to do this? Oh, you know what I should do? I'll try to color code it, the different amounts instead. How about that? 800 and 800. Oh, my 8s look like 1s today. They're so tight. Okay, let's do that. All right. So, we want to know, okay, what's the most an investor should be willing to pay for this investment? Okay. And so let's see here. This $800, I can trace it back to some present value. Okay. And remember, I use subscripts to denote just the order of my calculations. Okay, it's not so important here because it is just going to be a series of present values, but later on it'll denote the order of my calculations. Okay. But now it's just to keep them separate, right? If you don't have the color schemes, I need to show what they all are. So now here, if I add up all these present values, I don't know why I did P1 on the green one, it's P2. Right? The total value today that the maximum that I would be willing to pay today is P1 plus P2 plus P3. Okay, and so this is the total value of the investment today, if I add all of those up. Okay. All right. Next thing I want to do is I'm going to put the time on each of the arrows. Remember, time is in years for simple interest. And so here, the length of this arrow, right, is the time. So in this case, this time is 4 out of 12 months. Right? You try to just match the units, right? So 4 months from now, well, that's 4/12 of a year. Okay. Here, T2, I guess, is 8/12, and T3 is 12/12, which is 1. Right, but I'm going to leave it as 12/12 just for symmetry. I'm going to put a little subscript there. And okay, we're doing great. Money earns a rate of return of 6%. Okay, so somewhere in here, I'm going to have R is 0.06. Okay. It applies to all the arrows, which is not necessarily the case, right? You could have different rates for each of these, and it wouldn't, we'd be able to deal with that, right? Because we're just solving for these P's individually and then adding them up. Yeah, maybe I'll highlight that here. The total value of the investment today is P1 plus P2 plus P3. Okay. One thing that I do like to do, right, is even though I really only use this formula, the future value is P times 1 plus R times T. I anticipate solving for P 3 times, right? I can see that I need to solve for P 3 times. And so to save a little bit of time, I'm just going to rework this, solve this for P. So P is the future value over 1 plus R times T. Okay. Now I can go ahead and use that, right? And so first things first here, P1 is the future value over 1 plus R times T. Okay. Remembering from way before the break, everything on the left-hand side of a time arrow is a present value, right? Or a principal amount. And everything on the right is a future value, right? So the future value of this amount is $800. So I get P1 is $800 divided by 1 plus the rate is 0.06 for each of these, and the time for this first arrow is 4/12. I'll extend this here. Okay. P1 is going to be, let's see here. Wonder if I can do it. Yeah, I'm going to use, where's it? There. The scientific calculator for Desmos. It's 800 divided by, because this way, as long as I wrap it up in brackets and I make sure that I'm using the right calculation, then I can just go ahead and use it. 0.06 times 4 divided by 12. Step out of the brackets and the brackets, and I get 784.31. Now, what I'm going to do is I'm going to do all three calculations and then screenshot it and then bring it in. So I'm not going to write it down yet. Okay. So here we did solve for P1, but what I'm going to do is, well, first I'm going to make myself a little bit more room here. And then I'm going to go ahead and solve for P2 beside it so it stays on one page. P2 is the future value over 1 plus R times T. So P2 is also $800 divided by 1 plus 0.06 times 8/12. Notice that the only thing changing is the time. So you don't want to forget to change it, otherwise you'll have the same value over and over again, right? But they're basically the same. So if I add that to my list here, right, 800 divided by 1 plus 0.06, or maybe I'll do it properly, 0.06 times 8/12. 769.23. Again, I'm going to finish the last calculation before I bring that in, but I will bring it in, promise. Notice how we're doing the same thing over and over and over again, right? 800 is being pulled back. So 800 is the future value and T is 12 over 12 or 1, right? To find that present value 3. And so I have 1 plus R times T. P3 is 800 divided by 1 plus 0.06 times 12 over 12. Do the same thing again. You don't need this bracket as long as it stays in the denominator, but this forces it to stay in the denominator. So that's why I use it. 1 plus 0.06 times 12 divided by 12. I don't like to simplify things too much here because sometimes it can be time consuming, or I might mess it up, or I might round when I shouldn't be, right? And so here, this is, move that little tab thing. This is what I'm going to bring in. Oh. And crop. So this is P1 and P1 in dollars, right? Because I have the full amount here. So now I can just write it in dollars is 784.31. P2 is 769.23. And P3 is 754.72, right? Rounding properly. The 1 is followed by a 6, so then it has to be rounded up. Okay. Good. So one thing that I want you to really start relying on is, okay, if the future value is 800, I'm expecting my principal amount or my present value to be less than 800, right? They're not going to say, oh yeah, give us your $800 and or $820, and then we'll give you 800 in 4 months. That's not how interest works, right? And so we're expecting all of these values to be less than $800, which they are, right? I'm also expecting the payment that sits there the longest, right? The 12 months should also be the smallest principal amount, right? If I go to the bank and I say, here's $754.72, right? And if the interest rate is 6%, right? Then in a month from now, or sorry, in a year from now, I'll have $800, right? Same thing, 769.23, right? A little bit more that I have to invest, but in 8 months, I'll have $800, right? So see how these are all equivalent payments. And then same thing, 4 months. If I'm only letting it sit there for 4 months, I need to bring $784.31, and it can sit there for 4 months and grow to be $800. So that's kind of the key part to remember about the time value of money, right? We invest some smaller amount and it grows to a bigger amount, right? Or kind of on the flip side, not as fun, right? I borrow some amount, but I have to pay it back with interest, right? Which are all kind of concepts that we know and don't necessarily love, but it is what it is. You know what? I think I'm going to delete these because I want to fit this whole example on one page. And I didn't really need them. There. Okay. That's not the end of the question though, right? What is the most an investor should be willing to pay for this investment today? Right. And so the total value of the investment today is P1 plus P2 plus P3. Okay? And so the total value P1 plus P2 plus P3, which is, and let's get this up. 784.31 plus 769.23 plus 754.72. I'm just going to steal it from my notes here, 2,308.26. Even though it's unremarkable, right? If I said, oh, if you give me $2,300 today, I'll give you $800 4 months, 8 months, and 12 months from now, right? That's a good deal because the value of that today is $2,308.26. So you're saving $8.26, but that's how these banking offers work, right? You're not going to save a ton, but it is less than the market value, right? And so, so that's kind of fun, right? If someone said, hey, if you give me $2,000 today, I'll pay you back $800 in 4, 8, 12 months from now, what would you say? Oh yeah, take my money, you got it. Because then what are you making? $308.26, right? No one would do that, but if it happens, you know what to do. Okay. So what we did here is called discounting, right? When we draw things back to its present value, that's called discounting. Okay. So in example, I think it's 159, but let me check. Yeah. We found an investment's present value, which is called discounting. Okay. Let me just define it properly here. So discounting is the process of calculating a payment's present value. The process of calculating a payment's present value. Yeah. Let's do another example. So this is the one that I snuck in there. And so you might need to jot it down, but it's a short one. I just felt like we maybe needed some more practice. There. Calculate the fair market value of the scheduled payments 60 days from now if money can earn 8.5%. The payments are $1,000 today, $1,500 in 70 days, and $2,000 in 210 days. Okay, and so this is getting a little bit more complicated. Okay, and so what I want you to do is first things first, right? We read the question just like we did now, and then what we're going to do is we're going to try to figure out what all the dates are. Okay. And so calculate the fair market value of the scheduled payments 60 days from now. Okay. Now, when I have 60 days from now, I should probably have a now or today tick, even if it's just a reference point, right? And so what I'm going to do here, right, is I'm going to highlight that those two are going to be ticks. Okay. Luckily, right, there's also a payment today. So today and now are, of course, the same thing, but I'm going to highlight them anyways. And then in 70 days and in 210 days. Okay. So this tells me that I need to have 1, 2, not this one because I already counted it, 3, 4 ticks again. Okay. So, right, even though these timelines may not make sense, right, it's a way of making sense of the question. So that's where I want you to start. Figure out what the dates are that you need to put on your timeline, and then just start drawing the timeline, right? And it's going to be weird in the beginning, probably, but that's okay. Let me see here. Okay, so start with my timeline here. And we decided we needed 4 ticks. Okay, 1, 2, 3, 4. I've already drawn 2. Notice that I don't spend any time on the spacing, right? It's just to visualize the problem. Only if it's very obvious would I do that, but usually I just go for even spacing, right? Because then you draw what the amount of time is on the arrow anyways, so I think it doesn't really matter. Okay. So in terms of the ticks, right, they're all starting, so from today, right? And so that means that today is going to go as the first tick, right? So now I'm organizing these chronologically. 60 days, then 70 days, and then 210 days from today. Okay. All right. That's good. What's the next thing I want to do? The next thing I'm going to do is I'm going to put the dollar amounts underneath the appropriate tick. Okay. So the payments are $1,000 today. Okay. And I'll try to make it color coded again. Okay. $1,000 today. 1,570 days. And 2,000 in 210 days. And I'll put these I'll put some dollar signs on here. Okay. So now what we want to do is we want to calculate the fair market value of these payments 60 days from now. So notice how there's no payment here. That doesn't mean that there can't be, right? But we want to know the value 60 days from now. Okay. So this would be our focal date, right? What's the value 60 days from now? All right. If you kind of place your hand over today and ignore it for just a minute, right? So just ignore this. In fact, I'm just temporarily going to do this. Okay, so just ignore this section for a little bit. when you look at 60 days, 70 days, and 210 days, if you want to know what the value is of these two payments at 60 days, that's exactly like the question that we just did, right? No, it's not. That was to today. Oh, well, doesn't matter, right? It's just some amount of time. And these payments are being, and so I like to take my fingers and I like to just draw my arrows with my fingers, right? Because then I can kind of visualize it. Okay, these payments are future values and I want to draw them back and I want to solve for the present value. Okay. So this 1,500 is worth something at the 60-day mark, right? And because it's being pulled backwards, it's a present value. Same thing with this $2,000 or this pink one is also worth some present value right at the 60-day mark. Okay. So these are exactly like what we said before. It's just a little bit tricky, right? We have to keep our wits about us. 60 days to 70 days, that's only 10 days, right? So T here is 10 over 365. 210 minus 60 is what? 150. So here time is 150 days over 365. We're not going to ignore today forever, right? But I just wanted you to see that, okay, if you break it up into parts, we've already solved this problem, right? We had 3 present values to calculate earlier. Now it's just 2, but there's a but. Okay. This little guy, this $1,000 also has to be pulled to the 60-day mark. The difference is that it's being pulled forward, right? So that $1,000 is going to be worth more than $1,000, right? Whereas these 1,500 and 2,000 are going to be worth less, right? As we pull them backwards. So here, future value 3. Since there's only one future value, you don't have to put a subscript on there, but I use the subscripts usually to just highlight the order of my calculations. I use subscripts to highlight the order of my calculations. And I guess I need another line here, just a sec. Okay. Maybe I don't need so many arrows because arrows mean something here. There, do a little asterisk. So what we're asked to find is, what is this value? What's this total value 60 days from now? Okay, so what I need to do is I need to draw all these payments to 60 days from now. And then find this total value 60 days from now. Yeah. The only thing missing here, right? I need to have the dates. I need to have the dollar amounts. I need to have what I'm solving for. I need to have time. I also need the rate somewhere. Luckily, the rate is the same for all of these. So I'll just jot it down here, maybe over here, the rate is 0.085. It doesn't really have a spot. Oh, I do see something I forgot though. Forgot to put the time on this one. Luckily it's easy, right? Between today and 60 days from now, T is 60 over 365. Now I think I got it. We'll find out when I try to solve a problem. Okie dokie. Let's get to work. So the total value 60 days from now, I'm going to do the same thing where I'm going to solve them side by side, but that's just so I can keep them on the same screen usually, right? And so P1 is the future value over 1 plus R times T. The future value in this case is 1,500. R is 0.085 and T is 10 over 365. I'm going to set up all these calculations and then I'm going to do them in Desmos all in one go. Oh, next one, next step, pink. P2 is the future value over 1 plus R times T. P2, future value is 2,000 divided by 1 plus 0.085 times 150 over 365. And then just slightly different, right? A little bit simpler even. I need to find the future value 3. Now the future value had a principal amount or a present value of 1,000, and then it was sitting there for 60 days. So the future value 3 is P times 1 plus R times T. 1,000 times 1 plus 0.085 times 60 over 365. Okay, let's see if I can do that thing where I, oops. Wow. I have never done that before. It's like on top of the screen. I'll never figure out all the things my little iPad can do. All right. Cool. How do I? Can't seem to move it. That's okay. I'll just do it here. 1,500 divided by, so tiny. 1 plus 0.085 times 10 days over 365. Step out, close the bracket. You always want to be checking your work, right? Does that value make sense? Yes, it does, because it's less than 1,500, but not a lot less, right? 1,496 and 51 pennies, right? So not a lot less, but it is less, right? Same thing, $2,000 divided by 1 plus 0.085 times 150 divided by 365. Oops, not down there, but up here. Close the brackets. Again, just checking in. It needs to be less than 2,000, so 1,932 and 50 pennies. And then finally my, oops, my future value is 1,000 times 1 plus 0.085, oops, 85 times 60 over 365. 1,000 is going to grow, right? $1,013.97. Now, there. I'm going to take a screenshot here. Whoops, if I can. There. Oops. Crop out all that excess space. I'm just trying to keep it. I've got a page break here, so kind of tricky to deal with, but I think it's okay. So this P1 equals that, P2 equals that, and future value 3. So the total value, or the fair market price, or the fair market value, right, is the total value, is P1 plus P2 plus future value 3. So therefore, the total value 60 days from now P1 plus P2 plus future value 3, which is, and I'm going to round my dollar amounts now. It's not going to make a huge difference, but technically these are all separate payments, so they would still be money, right? So we would round them. 1496.51 plus 1932.50 plus 1013.97. I get 4,442.98. Good. So that's the value of all these payments 60 days from now. Okay. All right. Okie dokie. Third on my screen here. All right. Good. We're gonna do example. Hey, why is this here? Oh, cool. There. Let's do example 163. Now this one is quite tricky, okay? At least to read and figure out what you need to do. The calculations themselves are just future values or present values. That's all we're basically doing, right? But figuring out how you're going to solve for the final answer is the tricky part. Okay, so what I want to do is I just want to give you just a couple of minutes, and I'm going to pause the recording this time, and hopefully I remember to start it, and just try to set up the timeline for this. Okay, so just a couple of minutes to set up the timeline, and solve it if you want to, but setting up the timeline is the hardest thing. So I'm going to pause this. Welcome back. No time passes in the video. It's kind of funny. Okay. Kind of a doozy, right? There's a lot of time points to keep track of. Okay, but let's just start there, right? Just always start with the time points. So 4 months ago, okay, which means that I'm going to need a reference point for today, right? So today there's 4 months ago. Okay, so far I have 2 time points, and it's this one that throws me off for sure, right? Because I don't see it, right? I just say, okay, 4 months ago, and then right, and then the payments and whatever. But let's just keep going. So just keep track of that ago as well, which means you need today. Okay. Teresa borrowed $1,000 from Josh. Maybe I should read the question completely first. And agreed to repay the loan in 2 payments to be made 5 and 10 months from the date of the agreement. The date of the agreement was 4 months ago. Okay. Each payment is to consist of $500 of principal and interest at the rate of 9% on that $500 from the date of the agreement. Okay. Today, okay, so here we are today, Teresa's asking Josh to accept a single payment 3 months from now, right? So 3 months from today to settle the debt. What payment should Josh require if money can now earn 7%? Uh-oh. So all of a sudden there's 2 interest rates at play here. So we need to really, really keep track of all these things. We have all these skills, right? But it's just many questions thrown into one question. Okay, so that's the hard part. So let's start picking away at these dates. So 4 months ago, I'm counting that. So I need one today, right? And it comes up later too, we saw, but 2 payments to be made 5 months and 10 months after the date of the agreement. Okay, so that's going to require a little bit of work, but that's 2 more dates that I need to put on here. Today, okay, we have a spot for today already. It was the 4 months ago. Okay, Teresa is asking Josh to accept a single payment 3 months from today, making a 5th tick to settle the debt. Okay, so even if you have no clue what to do here, okay. Oh, and 3 months from now, okay, start with making the timeline. All right, so we figured out that we need 5 ticks. So same thing, I just spread it across my entire page, and now I'm gonna fit in 3 more ticks here. 1, maybe that's a little too, 1, 2, 3. I like to have them evenly spaced. It gives me more room. Okay. Chronologically, okay, 4 months ago, so 4 months from today, and then 2 payments. So the first payment is made 5 months after 4 months ago. Okay. So very difficult, right? But you just need to kind of stay calm and just sort these out. Okay. And if it helps, right, you could kind of write out the times chronologically, right, first. So you have 4 months ago, and then you have today, and then you have 5 months after 4 months ago, which is really what? 1 month after today? Let's see here. and then 10 months after 4 months ago is actually going to be what, 6 months from today. Okay. And they'll bump this down a little bit more, right? Because this is the hardest part, right? Sorting out all these dates. And then the next one, the final one, where does this 3 months from now? Well, 5 months. So 1 month from today and 6 months from today, which means that this one's going to get bumped down. And then I need to squeeze in 3 months from today. Okay, so that's the order of the ticks on my timeline. Okay, 4 months ago. And then today. And then this is 5 months. From date of agreement. And then we have 3 months from today. Set up. And then we have 10 months from the agreement. Okay. So those are the time points. And like I said, that's going to take a lot of practice, right? Reading these and trying to sort out all the dates. Okay, but we did it. Okay. Now to figure out what the scheming is here. Okay. So Teresa borrowed $1,000 from Josh. Okay. And what she said was, okay, I'm going to split this 1,000 into 2 $500 payments because I'm going to pay you back $500 or the equivalent of $500 5 months from now, and then the equivalent of $500 today, 10 months from now, okay, which means that she has to pay interest on it. Okay. So how I'm going to show that is I'm going to have, and I'm going to try to use the different colors that I have. $500 and $500. Okay. Adding those up is the $1,000 borrowed. Yeah. Okay. So the initial repayment schedule looked like this, right? So what did it look like? It looked like, okay, this $500, I'm going to pay you back the future value of this amount 5 months from now. Okay. On this arrow, right, the time of this arrow is 5 over 12 months. Okay. Okay. Now, because it's going to get confusing later. Oh, question, someone? If you have a question, let me know, but otherwise I'm going to mute you there. Or I think you muted yourself. Nice. Okay. So there's some future value 1. And what I want to point out is that the interest rate is 9% on the $500 from the date of the agreement. So for these amounts, the interest rate is 5%. So I am going to jot that down as well, because we already saw that it's going to change. I said 5, but it's actually 9. And the interest rate of 9%. Okay. That's for the initial agreement. This $500, she's going to take a little bit longer to repay, or 5 months longer, to be specific. Okay. And which means what? It means that she's going to have to pay back a little bit more, right? Because she's borrowing it for longer, and that's what it costs. Okay. So, but the rate is still 9%, and the time here, okay, 4 months ago, but 10 months from the agreement. So the time here is 10 months. Okay. Okay. This is the initial setup. Okay. Then here she is today. She says, you know what? Never mind. I am actually going to pay it all back 3 months from today. Okay. Which means that, it means what? It means that she technically has to borrow this future value 1 just a little bit longer, 2 months longer, right? Or 1 month. Yeah, 2 months longer. Okay. And so, yeah, getting all in my head with my dates. Okay, so she has to borrow this a little bit longer, so we need to increase that future value, right, and pull this future value forward. Now, this is the first time that we're seeing this, where a future value actually turns into a principal amount, right, or a present value. We're going to see it a lot, okay, but anytime there's any sort of agreement that goes something like, oh yeah, I'll pay you back 2 months and 4 months from now. Oh, wait a second, I changed my mind. I'm just gonna pay it all off 8 months from now, right? Then you have to basically re-borrow this money and pull it forward some more. Okay. So as long as you keep track of that arrow, right, on the left, you have the present value, and on the right, you have the future value, then you're good. Okay. Okay, so now we're dealing with the second half of the question. Today, Teresa is asking Josh to accept a single payment 3 months from now to settle the debt. Okay, what payment should Josh require if money can now earn 7%? Okay. So initially money earned 9%, now it only earns 7%. And so we want to know, okay, what single payment should she be paying 3 months from today? So what this is going to look like, and I'm going to use pink for this one because it is so kind of weird. And maybe what I'll do is the future value becomes the principal amount for payment number 3 that we're going to calculate. Okay, but we actually want to know what the future value 3 is. Okay, so notice here that these 2 payments are equivalent. So this future value 1 turns into principal amount 3, and then I know that dollar amount, so then I can find future value 3. The amount of time between 5 months from the date of the agreement and 3 months from today is 1 month from today and 3 months from today. So time is 2/12. And now notice that the rate is now 7%, so I need to change that. Okay. So this is showing that, okay, well, she borrowed it for 2 months longer, so she's going to have to pay interest, but the interest rate changed. So now she only has to pay 7% on that extension. Okay. And 10 months from the agreement date, well, that's further out. So now she's going to pay it back early, which means that she can discount this amount. And what color do I have here? Maybe this one. So that future value 2 is going to get pulled back to some principal amount 4. Now, 10 months from the agreement, and maybe what I should do or should have done is said that this is 1 month from today. And this is 6 months from today. Because I'm getting lost. There you go. So 6 months from today to 3 months from today, the length of this arrow is 3 months. So T is 3/12, and the rate here is 7% again. Right? So just notice that rate change. Maybe I can. Looks a little dark actually here. There. Okay. So then this future value 3 and present value 4, once I add those up, that's the amount of the single payment that she needs to pay. So this is the total, and I'll put in brackets single payment owing 3 months from today. I'm going to really rely on those subscripts to tell me the order that I meant to do these calculations in, right? Because otherwise I'll be extremely lost, right? And I need those two future value 1 and future value 2 in order to solve for the next two, right? So you want to really keep your wits about you. Okie dokie. Future value 1, and I should use the color scheme, is P times 1 plus R times T. The principal amount that she got was $500, and the rate 1 plus 0.09 times T, which is 10/12. You can see how simple the calculations are, right? It's not the calculations that are hard here, right? It's figuring out what you need to do, right? And what it's telling you. Okay, and so all the information is here on the timeline, right? Otherwise you haven't finished your timeline. So now it's just a matter of plug and chug, right? I'm gonna do, now I'm able to do it all the time. It's crazy. Cool. 500 times 1 plus 0.09 times 10 divided by 12. Step it out, step it out. 537.50. Oops. Is what she would have paid 5 months from the agreement date, right? I borrowed $500. Now I need to give you $537.50. Fair enough. The next one is very similar. The only change is that now, let's see. I don't like to crowd all my work like this, but it does make it stay on the screen. Future value 2 is P times 1 plus R times T, which is, again, she borrowed $500, but now she borrowed it for 10 months instead of 5 months. Oh, whoops. I had a slip up. I already calculated that one. Okay, no, you know what? That is right, but it's for the wrong value. Here, all I'm saying is, okay, make sure you keep track of which one goes with which calculation. And then I messed it up myself. So you have to be so careful. I have to be so careful. 5/12. Okay. I'm just going to do that calculation here real quick. 5, wait. Oh boy, why does it have? There. 500 times 1 plus 0.09 times 5 divided by 12. Right, I solved the one that we need next already, but hey, these are coming out to nice rounded values. Fancy. 518.75. Future value 2, 1 plus 0.09 times, now it's 10/12. And we just did it, but I can't remember what it was, so I'm going to do it again. 500 times 1 plus 0.09 times 10 divided by 12. Looks familiar. 537.50. Okay. I'm going to screenshot my own screen, I guess. Oh, there. Crop this out. There. Okay. So now what you could do if you wanted to is you could jot down these numbers on here, right? So $500 after 5 months is now she has to pay back $518.75. And $500 after 10 months, she has to pay back $537.50. Yeah. We didn't have those values on there earlier though, right? So don't let those throw you off. But now what we know is that, okay, well, then the principal amount, so now she has to basically re-borrow this money, right, for 2 more months. Okay, so now it's the same calculation over again. We're just pulling it forward for 2 more months, but the rate has changed, right? So now this is the same as the principal for future value 3. Okay. So future value 3 is P3 times 1 plus R times T, which is 518.75 times 1 plus, and just pay attention to the rate change, right? It's 7% now, just checking. And for 2 months. Yeah, just confirming. Same idea, right? She was going to have to pay back $537.50, but now she's paying it back early, but the rate has changed, right? So she's not going to be discounted as much as before, right? And so now she does get a discount, but not as much because the rate is lower, right? And so now we can find P4. P4 is future value 2, right? Because it was still a future value, so I'll just keep it as a future value. Here, this future value turned into a present value because I needed to reborrow it again. So that's why I have this kind of daisy chain going on here. But future value 2 divided by 1 plus R times T. So P4, and you know what? Just feels too weird. P4 is future value 2 is 537.50 divided by 1 plus that new rate 0.07. And how long was 3 months? 3 over 12. Oh, I didn't solve this yet. Maybe I will put it over here. Sorry, guys. A little confusing. I realized I haven't put it into the calculator yet. That's why I'm... Okay, we had future value. $518.75 times 1 plus 0.07 times 2 over 12. Oh, close the bracket, big brackets. And 524.80, but I'm also going to do P4 before I screenshot it here. And so it's 537.50 divided by 1 plus 0.07 times 3 over 12. Oops. 3 divided by 12 helps. Crop. This. Okay. So future value 3 is $524.80, and present value 4 is $528.26, right? Rounding properly. I think I just checking for maybe typos, though doubt I would see them anyways. All right. We're so close. Okay, so basically 524, 528. Okay, so those payments come together to make the total single payment 3 months from today, right? And so here 524 and 528, I think it was, or reversed, right? But then the total single payment owing 3 months from today is future value 3 plus present value 4. So the total single payment owing 3 months from today the total is future value 3 plus present value 4. And once I've rounded 520, oops, no typos now, 524.80 plus 528.26. See if I have this anywhere. I do. Is 1,053.06. Nice. That's a big one. Okay. Okay. So another thing that we're going to need to be able to do is, okay, well, what if I want to, what if I want my payments to be the same, right? So what if I want to have even payments? So, you know, I'm going to pay you $210 every 3 months for as long as it takes to pay off my debt, right? How many, so what is that? No, I just forced it to be $210. I'm going to pay you back some amount of money, and it's going to be the same every 3 months, right? For 3 years. Seems like a long time. Anyways, let me see if I can clarify what I just blabbed about here. Okay. So sometimes we will want to solve for some fixed payment amount, right? Where the payment remains the same. Sometimes we will want to split the payments in a way such that each payment is the same. Each payment is the same, right? So I have an example to show you, and here, right, I'm going to show you the trick, and we're going to use this trick a lot. Okay, so here, note, we will use the following trick. It's not a trick. We're just solving the problem, but people feel it's a trick. It's not. The following trick often. Yeah. So let's see here. I'll put it on a fresh page here. Okay. A loan of $10,000 requires 3 equal payments to repay the debt. Okay. And so here, 3 equal payments to repay the debt. The first payment is after 6 months, the second after 1 year, and the third after 1.5 years. What is the amount of the payments? Okay. And so, okay, so use today as the focal date. Yeah. So that's why I mentioned what the focal date is, because sometimes it's helpful, right? So what we're going to have is, okay, we've got today as our focal date. So obviously that's going on our timeline. And then there are 3 payments, right? 6 months, 1 year, and 1.5 years. Yeah. And so it looks like I have 4 ticks on my timeline. Now let's see here. The first payment's after 6 months, 1 year, and 1.5 years. Yeah, and then use today as the focal date. This one's easier in terms of our timeline, I think, right? But maybe not for the first time solving this kind of problem. Okay. So we have today, and then we're going to make some unknown payment 6 months, 1 year, and 1.5 years from today. Okay. The 3 equal payments, and this is the trick that we use, is I'm going to just use X to denote the payment amount. Okay, they're going to be equal payments, and so here, right, X, X, X. X is the same, right? Making each of these payments the same, right? 3 equal payments. Okay. Now, this X is some future value, right? It's a future value from today. Now, when it says use today as the focal date, right? So the focal date, what it means is it means to draw, the payments are all going back to pay off the $10,000 that you borrowed today. Okay? You would have used today as the focal date anyways, but sometimes it's nice because the question just tells you what to use. Okay? But when I draw this back, this becomes some principal amount 1. This becomes some principal amount 2. This becomes some principal amount 3. Okay. The total here has to be $10,000, right? That's how much I borrowed today. So this has to add to $10,000. How much, or the loan amount today? We have to pay it off with interest, right? But each of these payments is sitting there for different amounts of time, right? But we're forcing the payments to be the same. And this type of question, right, where we're figuring out equal payments, it could be something like the first payment is 3 times the second payment, and the third payment is twice the second payment. What would that look like? Then I would have 3x, x, and 2x, right? So you can have little variables on there, but we're starting nice and small, but you can easily grow into that pretty quickly. All right. So in terms of time here, it's relatively simple, 6/12. 1 and 1.5, right? Because time is in years. So that's not the hard part of this question, is it? So the rate of interest is 6%, and looks like it's the same for all of these. So I'm just going to put in R as 0.06. Okay. So let's go ahead and solve this remembering that X is the future value. Okay. And so I've got P1 is the future value over 1 plus R times T. The future value is X divided by 1 plus R is 0.06 times T, which is 1/2 or 6/12. I'm going to write all these out right away. P2 is the future value over 1 plus R times T, but that means that it's X over 1 plus 0.06 times 1. And I'm going to highlight the X in pink, right? Because that's the only new thing that we're learning in this question. P3 is future value over 1 plus R times T, which is X divided by 1 plus 0.06 times 1.5. Nice try. There. Okay. Now I'm going to go ahead and solve these. Okay. But what's going to happen? Okay. And the trick here is going to be, well, one, store all your values, right? Store all your fractions, because going back to what we learned about how fractions behave, I can pull these apart, right? I can write this as X times 1 over 1 plus 0.06 times 6/12, right? And so here, what this is going to become is this is going to become 1 over 1 plus 0.06 times, let's just change it to 0.5 for simplicity's sake, times X. Okay. So this is the trick in action. It's not a trick, it's just math, but 1 over 1 plus 0.06 times 1 times X. And this becomes 1 over 1 plus 0.06 times 1.5 times X. Okay. So what I need to do is I need to solve for, just looking at this looks a little weird. I need to solve for each of these fractions, and I'm going to need to keep them. I'm going to need to store these values. Okay. And okay. Let's see here. I think I can do A equals. Now, I haven't played around with this yet, so let me see here. If I can just store it in A is going to be 1 divided by bracket 1 plus 0.06. Six times 0.5. Good. Okay. The next one. So now I'm just going to try it because I haven't tried it before. Okay, so now it knows that A is that value, right? So that's a way to preserve all these, all the decimal places. If you're working in that financial calculator, I'm not going to pull it up because it's definitely going to play an ad or two. Then use the store function, right? But my next one, I'm going to call it B equals, and it's going to be 1 divided by 1 plus 0.06 times 1. I'm just putting it there for good measure. So notice that these are 0.9 something something, so close to 1, but not quite 1. But so they're going to be smaller numbers, right? And finally, C is going to be 1 divided by 1 plus 0.06. Oops, I forgot my brackets here. Uh, 1.5. There. Okay. So in terms of the math, right, I'm calling this A, this is B, and this is C. Okay. So this becomes A times X, right, where A is 0.9 708737864. I will screenshot it and bring it in. So, right. But then what I want to do is I'm also looking for P1, P2, and P3. They have to add up to satisfy the $10,000, right? That's my initial loan amount. Okay. So this becomes BX plus CX. All right. Let's see here. Oh, not yet. Delete. So P1 plus P2 plus P3 is $10,000. So we know, and maybe I can just start it on a fresh page. We know P1 plus P2 plus P3 must add to 10,000. So then what we're going to say is 10,000 is P1 plus P2 plus P3. I'm going to clean these notes up because I know they're going to end up huge. I'll clean them up before I post them. Which is the same as AX plus BX plus CX, which is what? I can pull out a common factor of X, right? And then I have A plus B plus C times X, A plus B plus C times X. So if I do A, is there a plus on here? No. Plus B plus C, I get 2.83170120 times X. Okay, I'm so close to being able to solve for X. Why? Because this has to be 10,000 still, right? Usually if the value doesn't change, we don't need to write it all the way down, but here it's a helpful reminder. So X must be 10,000 divided by 2.83170120, which I'm also going to do here. Let me see if I can copy this. Okay, no. But I can do 10,000 divided by that previous answer. So X is $3,531.45. This I'm going to screenshot and bring in because I know I'm out of time almost here. Wait. There. So this I knew would be kind of crazy here, but I'm just going to bring this in and crop it. So each payment, therefore, each payment must be 3,531 and 45 pennies. Okay. We didn't get to, so 4.7 is just general strategies for time value money problems, which we've been solving this whole time, right? And so I'm going to skip that, but I am going to wrap up 4.8, which is when the interest rate is changing, right? Next day. All right. If you have any questions, let me know. Otherwise, I'll see you on Wednesday. But I'll stop this recording here.